answers the question such as, is there like a vehicle ahead, or is the driver drifting out of the lane, or like is a collision likely. So all these systems gets or all the systems data goes into the vehicle processor there. So like is there any emergency braking be activated or not. So this algorithm makes decision within the milliseconds. Okay. And if I talk about from detection to safety, so here this slide you can see here this objective shows the safety because it reduces the human errors. Like you can see here the 94% of the crashes per NHTSA is detected only is only happened by the human errors. Okay. So the key objective of this ADAS system first is our safety. Okay, this is one of the most important objective we will say. So most of the studies shows that like approximately this 94% of road accidents just occurring because of human error, because there are some examples like driver distraction, and suppose you are driving your vehicle for 4 to 5 hour continuously, so there will be fatigue, and maybe for the over speeding and the late braking. So there the ADAS comes and it helps to reduce these errors through the forward collisions warnings, and like automatic emergency braking, and some blind smart monitoring, because you can't able to see all the things in front of your vehicle. So there the radar comes and it also helps in your like in the safety. Okay, and it also tells you the lane departure warning. So the goal is not like to eliminate the accidents completely, but to significantly reduce their occurrence. Okay, and then the second comes here is our comfort part. Okay, then when you drive, your long distance driving can be tiring. Okay, so imagine driving, you are driving your vehicle for 5 to 4 hours continuously on a highway. So the driver becomes fatigued that time, and the reaction time of the driver will automatically get decreased, right? And the mistakes will automatically get increased that time. So there also ADAS improves comfort through the adaptive cruise control. What? Cruise control. Okay. And sorry, uh, cruise control. Just listen to my word carefully, because my pen is not working that much clearly. Okay. And yeah, so some traffic jam assist also is happened or will detect through the ADAS system. So this feature reduces the driver workload and stress. Okay, and if I will talk about the efficiency, ADAS can also improve vehicle efficiency. Can anyone give me any example like how these ADAS systems help in improving the efficiency of the EV? Anyone, please unmute yourself and please give me answer. How it will increase the efficiency? Anyone?
Maybe selecting right driving mode for right conditions.
Yeah, like this is one of the example I will say, but especially like I will say the important, because driving means like better battery utilization, right? And to increase the driving range and to reduce the energy consumption. How it will help? Uh, for example, the ADAS system helps us to do the intelligence braking, right? So like in suppose you are in a traffic, okay, and that time you are not applying your brake, or you are not applying manually brake. So that time that intelligent braking automatically helps your vehicle to brake automatically. And I hope you have read about one concept, which is our regenerative braking system, right? So in the regenerative braking system, you have heard about while applying the brake or reduce or removing the removing the foot from you the accelerator, that time your energy gets converted into electrical energy, kinetic energy is getting converted into electrical energy, and it's sent back to the battery part. Okay, so this is how it increases the efficiency of your vehicle. And you can see here the foundation. So this is nothing but ADAS is like not the final destination, I will say. So ADAS is actually the stepping stone towards the like fully autonomous vehicle. Think of first human drive completely, then the ADAS assist the driver, and eventually become the vehicle become fully autonomous. Okay, so this is about just the introduction of our ADAS system. I hope everyone have understood this. Okay, so now let's move forward. Now let's see the common ADAS features. Okay, so as we have just uh, discussed, that ADAS is not just a single technology. It is like a completion, or a collection of, I will say that, multiple intelligent safety and the assistant features, which are working together. So each feature is designed to solve a specific driving challenge, such as you can see here, avoiding collisions, maintaining lane disciplines, detecting blind spots. Okay, and first you can see here is AEB, which is our auto emergency braking. Okay, now what is it? So yeah, so like AEB is automatically applies the brake if the system detects any imminent collision, and the driver fails to react in time. As you can see here in the picture, it detects the auto obstacles, and the vehicle applies the brake automatically. Okay, now the question comes here is, how does it work, right? So here the radar and the camera continuously monitors the road ahead, and here the system calculates the distance and the closing speed. Okay, suppose if the collision risk increases, it will give you the warning with the help of some beep beep sound, or something like it will display the light on your cluster part or the display part. Okay, so this is how you will able to saw that some collision is going to happen. Okay, and its benefit, I will say that it will prevent your rear end collisions, and it will reduce the accident severely. Okay, and the second one is our adaptive cruise control. Now what is it? So as you can see here in the picture, the cruise control, so it is like an advanced version of our normal cruise control. Okay, so like additionally, traditionally I will say like cruise control maintains the speed, and adaptive cruise control maintains our safe distance from the vehicles ahead. Okay, now how does it work? So using the same radar and cameras, this vehicle monitors the traffic ahead, and automatically accelerates or like decelerates. Okay, and maintains the safe falling distance. Okay, for example, suppose you are setting the speed of your vehicle at 90 km per hour. Okay, and vehicle ahead shows the 70 km per hour. Okay, so your vehicle will automatically reduce the speed that time. And suppose once the lane will get cleared, it will automatically returns to the 90 km per hour. Okay, and the benefit the driver will get is to reduce the driver fatigue, and it will be beneficial for, or will I will say like ideal for the highways, and it will also improve the safety. Okay, then the third feature comes in this ADAS system is LDW and LKA in short. So it is lane departure warning and keep assist. Okay, now what is it? So basically, these systems help keep the vehicle inside its lane. Okay, so this LDW, I will say this is lane departure warning, warns the driver when the like vehicle unintentionally leaves the lane. Suppose you are tired and your vehicle starts leaving its lane. So that time this lane departure will warning helps the driver to get attentive that time. Okay, and second one is our LKA. Okay, so it is like gently steers the vehicle back into its lane. Okay, for example, like a driver completely sleeps on the highway, so that time the car begins drifting towards like another lane. Like we all have seen, we get tired during the travel, so driver also get fatigued that time. So this ADAS system helps to helps the driver to stay attentive, and it will also give warnings, and it also shows the warning. Okay, this system basically detects just the lane marking and gives the warning. Okay, then the fourth feature comes here is BSD, which is our blind spot detection. Okay, like I will say you I will ask you some question like can you see everything around your vehicle using the mirrors? No one can see everything around the vehicle, because how you are sitting inside the vehicle, you can't able to see move your head 360-degree inside the vehicle, right? So you can't able to see the all the vehicles or surroundings sitting inside the vehicle. Okay, so every vehicle has a like a blind spot. So this blind spot BSD, blind spot detection, detects the vehicle hidden in the blind spots. Okay, so now question comes here, how does it work? Because as we have seen that all these three features works on radar and the sensors. Okay, so this radar sensors monitors the adjacent lanes. Okay, suppose if another vehicle is present, it will give warning light, which will appears on the ORVM, or it will be audible warning may be generated inside the vehicle. So the driver can easily identify the vehicle is in the blind spot, or he has to move his vehicles slowly. Okay, so this is one of the fourth feature, which is our blind spot detection. Then the fifth feature comes is our under the ADAS is our TSR, which is traffic sign recognition. Okay, so this system basically reads the road sign automatically. And how does it work? So it just like front camera in this vehicle front camera identifies the speed limit, or no entry sign. As you can see here in the picture, it is shown 60, but sometimes the board shows the cross sign as well. So there are some no entry sign. This camera also identify these signs. Okay, stop signs or overtaking restrictions. Okay, for example, like your vehicle is passing at a 60 km/h. Okay, and the speed limit sign is given here. Okay, so the speed limit is equal to 60 km/h on the instrument cluster, same as well. Okay, as you can see here, it automatically adjusts the speed of your vehicle. So the benefit gets, it prevents the overspeeding as well. Okay, and improve the compliance with the traffic rule, I will say. Okay, then the fifth or sixth, yeah, sixth feature comes under the ADAS system is auto parking as assist. Okay, now what is it? This is basically this basically feature helps like parking the vehicle automatically. As you can see here in the picture, there are two vehicles around this vehicle, and this vehicle is getting automatically parked inside lane, right? And how does it work? It is using the ultrasonic sensors, okay, cameras and steering control. Okay, these all things combine together and helps the vehicle to get automatically parked. Okay, so this vehicle just identifies the parking space and performs the parking maneuvers. Okay, then the sixth feature is our DMS, driving monitor system. Okay, so basically this system monitors just driver attention or alertness. Okay, so in a cabin camera there are some cameras which are placed inside the vehicle as well. that they just continuously capturing the driver face motions. Okay, and it is continuously absorbing the eye movements of the driver, or the head position, or how many times a driver has blinked. Okay, so it is continuously monitoring all the driver's face. Okay, blink rate, face orientation, all those things. So okay, so this is one of the I will say the best more feature of our ADAS system is driving monitor system, because all the cameras are outside the vehicle, but one camera must be inside. So it is the driving monitoring system which continuously monitors the face reaction, or I will say the eye movement, blink rate, all those things. Okay, then the last feature is our comes under the ADAS feature is our NVS, which is our night vision system. Okay, so this night vision helps driver to see the objects that are difficult to detect at night, right? So it uses the infrared cameras, IR cameras, which is our infrared cameras, or thermal imagining sensors, thermal imagining sensors. It helps the driver to see the objects at night. Okay, and it helps to identify the animals, because we can't able to see the animals. Suppose a dog is running and crossing the lane, so you won't be able to see the, because at night. So there is a use of infrared cameras or the thermal imagining sensors which identify these animals or obstacles, okay, beyond normal headlight range. Okay, so this is these are the some most important 8 main features of our ADAS system. Okay, now we have understood about the ADAS system. Now let's a little bit discuss about the market size, because as we all know that this ADAS technology is getting so much uh, fame, or I will say that the uh, share into the market. Okay, so as you can see here, that the ADAS industry is like one of the one of the fastest growing sector in the automotive world. Like as you can see here, according to market estimate, you can see here in the 2022 it was around 27 billion dollars, and you can see here by the end of 2030 it is projected to reach around 74 billion dollars. Okay, and this is shows the compound annual growth rate of 14%. CAGR means compound annual growth rate. Okay, suppose for example, if you invest money and it will grow every year, what do we call that growth? That rate is called as compound annual growth rate. Okay, so as you can see here, the ADAS, the compound annual growth is around 14%. So like this market is expanding aggressively every year due to like increasing the demand for vehicle safety and automation. Okay, so and we all know that why this ADAS technology is growing, because of the safety reasons, right? As you can see here, some regulatory mandates, Euro NCAP or NHTSI, are accelerating adoption. Okay, so as you basically this Euro NCAP is nothing but just a European new car assessment program. Okay, I am bad at writing here. Just listen to my word carefully. Okay. So this Euro NCAP is new car assessment program. Same applies in India here, which is our Bharat NCAP rating, which is the safety rating given to the vehicles which has ADAS system inbuilt. Okay, so these rating especially gives to the vehicle which are best for the safety. Okay, so this is nothing but just I want to show you the how much this technology is growing. Okay, and suppose if you are going into this technology, or you are building your own coding, or you are making your own project on the on ADAS system, so it will like growing much faster. So you can able to make your future bright into this sector as well. Okay, so this is one of the like best example I will say. Okay, now let's see some see about this sensors which are used in the ADAS system. Like no single sensor can. Just give me a minute. I will drink some water. Okay. Okay. As we all know that like no single sensors can handle every situation. Okay. Like can a human a human drive can using only eyes on like no ears? Obviously not. Like we use eyes to see and like ears to hear. Similarly, and the autonomous vehicles also needs like multiple senses, and each sensors has strengths and weakness. Okay, as we'll see here, as we you can see here the table which is given here. Okay, so four major sensors which are used in the ADAS is radar, lidar, camera, and the ultrasonic sensors. Okay, so basically radar. This radar works by transmitting the radio waves. Okay, and the waves hit an object and bounces back by measuring the reflected signals, and the system then calculates the distance or the relative speeds, or I will say the direction. Then it will show you the warning signs. Okay, so as you can see the range according to this radar system is given here is up to 250 meter. So this radar can senses up to 250 meter of range. Okay, so like this make the radar the longest range ADAS sensor. Okay, and you can because its resolution is low, but the weather performance it has is excellent. Okay, so like it works extremely well in the rain, fog, dust, snow. Okay, so yeah, and if I talk about lidar sensor, which is our light detection and ranging. Okay, this is our lidar sensor. So this lidar works similarly to radar, but uses the laser light instead of radio waves. Okay, so this is using the laser light uh, instead of radio waves. So it emits like thousands or like even millions of laser pulses every second. Okay, so these pulses create a detailed 3D image. Okay, so uh, this sensors helps in detailing the 3D map of the environment, and its range you can see here is up to 200 meter, and the resolution it has is very high, and the weather performance is also good. And if I will talk about the camera, we all know that how this camera works, and we will also get deep into this in the next slides. Okay, I have prepared some dedicated slides for each sensor in the next slides. Okay, and the camera can captures up to 100 meter. Okay, and the resolution is also high, and the weather performance is moderate here. And the ultrasonic sensor is ranges only up to 5 meter. Okay, so and the resolution is low, and the weather performance is good in this sensor. Okay, now let's move forward. Okay, now you can see here which is our first sensor, uh, which is our radar, radio detection and ranging. Okay, so basically this radar stands for radio detection and ranging. And how it works, the question comes here is how it works. So as you can see here, the center image, it emits the radio waves. Okay, and you can see here the reflected waves when it emits, and the it back gets the reflected waves. So the first step comes here is the transmission. The first step comes here is the transmission. So the radar antenna you might have seen on the vehicles, the radar antenna sends the radio waves towards the nearby object. Okay, so these waves travel at the like speed of a light. And then second thing comes is the reflection. Okay, so when the waves hit an object such as like car, truck, motorcycle, so anything it will be, so like they bounces back towards the radar sensors. Okay, so these are called the reflected waves. Then the third thing happen inside this is our signal processing. Okay, the third thing happens after the emitting, then reflecting, the transmission, then the reflecting, then the third thing happens is the signal processing. So the radar ECU analyzes the like returned signals and calculates the distance. Suppose you can see here there is certain some distance here. So the radar is calculates the distance using the time of flight principle. Which principle? Time of flight principle. So basically this is the longer the return time, basically this yeah, this time of flight principle tells us the longer the return time, the farther the object, the farther the object. Okay, then the you can see the if we have to detect the speed, we use the Doppler effect here. Which effect? Doppler effect. Suppose if an object is moving towards the vehicle, okay, the frequency will increases that time. Or suppose if the vehicle is moving away, and that time the frequency will automatically get decreased, right? So this allows the radar to like determine the relative speed. And if I will talk about the angle, and because using multiple antenna arrays, this radar identifies whether the object is straight ahead or left side or the right side. Okay, so this is what antenna does. And why this radar is important, because radio waves can penetrate in the fog, or I will say rain, snow. So this makes the radar like one of the most reliable radar sensor. Okay, and as you can see here, the types of automotive radar is short range radar, medium range radar, and the long range radar. And you can see here the ranges of all these three. Okay, so as you can see here, the use of this is parking assist, blind spot detection, medium radars, radar crosses, traffic alert, lane changing assist, and the third, which is long range radar, which can cover the range up to 250 meter. Its use cases only for the AEB, which we have discussed in the features part. Okay, so which is our adaptive cruise control, which is basically mostly used in the highways. Okay, so this is these are the types of radars. Okay, and you can see here some frequency bands as well. Let me just rub some part here. I will write it again clearly. Okay, so as you can see some frequency bands here, bands here. Okay, the first is here mentioned is 24 gigahertz. So this is basically the old generation radar. Their characteristics, I will say, like it has a larger antenna. But nowadays, you have seen that vehicles don't use that much larger antenna. Okay, and it is also lower resolution. And then the 77 to 79 hertz gigahertz, uh, it is used in the currently in the automotive industry standard. So there are some advantages is because it has smaller antenna size, and it can able to detect longer. Okay, so like most modern ADAS equipped vehicles, this 77 gigahertz of radar. And here you can see here one more thing, it is our 4D radar emergency. So basically this is one of the newest development in the ADAS system. It uses the XYZ plus velocity. Okay, so basically this 4D radar adds the elevation, I will say, the Z part. Okay, because this means like a radar can now understand the height, vertical position, and the road geometry as well. Okay, so along with the speed and the distance, as you can see here, the speed with distance, it can easily understand all the position. Okay, so you can see here the x-axis, y-axis, and the z-axis. So z-axis here show the elevation or the height of a vehicle, and here is the velocity, because the object is the object moving this is like moving speed object. Okay, so together this form the 4D. So that's why we call it as 4D radar. Okay, and because why it is important, can anyone tell me why is it important we have to use this 4D radar? Anyone? Why we have a need of this 4D radar system? Can anyone tell me please?
Maybe
Anyone?
because vehicles like trucks have higher heights.
Yes, exactly. Because suppose you have seen that when you will pass from the bridges, there you might have seen that there is a like barrier, this suppose there is your vehicle height is around 5 meter, or your truck height is around 3 meter or 4 meter, whatever it is. Okay, so there is like a barrier, it has shown that you can't pass your vehicle from that highway or from that bridge. So this radar helps the vehicle to move forward. Okay, so this is like one of the best example, I will say, for in the 4D radar sensor which is used in the emergency braking. Just a second, just give me a second. Just give me a second. Okay, am I audible? Okay, okay. Okay, then the second sensors comes is our lidar. Okay, so basically lidar is nothing but just a light detection and ranging system. And how does it works? Basically lidar uses the laser light instead of radio waves, so it continuously sends the laser pulses toward the surrounding objects and measure how long the reflected light takes to turn. Okay, and it uses the million of measurements every second. So lidar creates an extremely, like you can see here, the detailed 3D presentation. Okay, so of the environment. So why is lidar important? Because it is like self-driving car needs to identify a pedestrian, bicycle. Okay, so this is, that's why we use this lidar system. Okay, and how does it works? Because it consists of basically three major steps, I will say. First you can see here is our laser pulse emission. Okay, then second is time of flight measurement, then the third one is our 3D point cloud. Okay, so this laser pulse, this lidar sensors continuously emits laser pulses. Okay, like common, it has a common wavelength of around 905 newton meter, and 1515 newton meter. So these laser beams speed across the environment, spread across the across the environment. Then the second step comes is our time of flight. Just before I have discussed you with you that this time of flight, that just like radar measures the time travel of radio waves, the same in the lidar measures the travel time of the light. Okay, so this basically system calculates the speed of light into speed of light. Sorry, let me just write it here. Speed of light into time taken, distance equal to. Okay, so since like light travels extremely fast, so the measurements are very accurate, right? Then the third steps comes in this lidar system is the 3D point cloud. Okay, so this is like the biggest advantage, I will say. So in this, every reflected laser pulse becomes like a point in a space. Okay, so million of such point creates like a 3D cloud. As you can see here, a 3D object is here you can it represents the 3D object. So same as in the case of when you will drive your vehicle in the road, there it creates a 3D map of the whatever the environment, whatever the surrounding is around your vehicle. Okay, so suppose when like you can see here towards the like you can see towards this image, then there is like a car is representing by thousands of points. You can see here there are thousands of points, so the pedestrian is represented by thousands of points, and you can see also the trees and the buildings are also represented here, right? So lidar doesn't see object like a camera, but instead it sees them as a collection of precise in 3D coordinates, I will say. So this allows like autonomous vehicles to understand the shape, size, and the position very accurately. Okay, and like one question comes also here is like why lidar is superior for the 3D mapping. Okay, so basically radar can tell us up to like 100 meter ahead, and camera can tell us it looks like a pedestrian. So lidar can tell us the exact location, exact shape, exact dimensions. So this is why lidar is heavily used in the autonomous driving research. Okay, as you can see some types of lidar, it is our mechanical spinning, MEMS, OPA, and the flash lidar. And what basically mechanical spinning is, it is this is basically the traditional lidar design. This the sensor physically basically rotates to scan the environment. Okay, and in the MEMS it is micro electro mechanical system, micro electromechanical system. So instead of rotating the whole sensor, tiny mirrors or redirect the laser beam in this MEMS lidar system. So if I talk about this OPA, optical phased array, this is one of the most advanced lidar technology. Instead of mechanical movements, it uses the electronic beam steering. What it uses the electronic beam steering, and this laser beam is controlled electronically. Okay, in this system. Then the fourth one comes is our flash lidar. So this flash lidar works similarly to like a camera flash. Instead of scanning point to point, entire system is illuminated at once. Okay, so this is one of the best type of lidar system, and their pros and cons are also mentioned here. You can see this. Okay, now let's move forward to the yeah, one of the like key metrics and advantage I will say here of the this lidar system is you can see here some images as well, right? How this lidar detects the or detects or do the mapping. Okay, you can see here some images and the advantages as well. There is very high spatial resolution of any sensor, precise it has also precise 3D mapping, accurate depth perception, and the shape recognition, and it creates the detailed environmental map, right? And Also, you can see here the key metrics are the range is given here 100 to 200 meter depending on the reflectivity of the target. And also you can see here the point cloud density, which is how many points it creates to just to do the 3D mapping. Okay, you can see here the image. And one is the field of view, which is our 3D, 360-degree spinning. So basically, this typically found in the spinning lidar we have mentioned just read before. This comes in the spinning lidar because it rotates 360 degree and complete the surrounding coverage. So there is no blind spot left. And one is the 120 degree, which is our field of view. Okay. Then the last key metric is over the wavelength. So lidar basically system commonly operates as two wavelength, which is 905 Newton meter and 1505 Newton meter. So basically this 500 905 Newton meter is currently the most common automotive lidar wavelength. Okay, because it is closer to visible light. And eye safety regulation limit the this laser power, so this limits maximum range. Okay, and if I talk about this 1550 Newton meter, a newer or the more, this is the advanced technology. And the advantages in this, it is also for safer for the eye at higher power levels. Okay, so this is about the lidar system. Now let's understand about the camera systems. Okay, now why cameras are important in ADAS system? Because uh, as we can see here, to capture the images, to detect the obstacles, all those things helps cameras helps us to detect all those things. So in this you can see here that the what camera just this camera continuously captures the images of the surroundings, just like a smartphone camera records the like photos and videos. So and here one more thing comes here in this, that the computer vision processing. So basically the images are sent to the powerful processor which are running, like computer vision, machine learning and deep learning algorithms. Okay, so the basically software analyzes the images, then the object understands, how the system identifies the lane markings, vehicles, cyclists, etc. So yeah, then it after this it do the decision making. Okay, then basically what the camera sees, the ADAS controller decided should the driver be warned or not, and should braking be activated or not. So all those things is happening because just to make the decisions. Okay, and basically the camera location in the modern vehicles, as you can see here, some these all are cameras which are placed in the fitted with the vehicle here. So here you can rear view reversing. First we have can see that the front monocular camera, it is only used for lane detection, traffic sign recognition. Okay, second is our stereo, why do human have just like the human see by their eyes, same the stereo camera works. So like two cameras capture image for slightly different angles. Okay, so using the triangulation to system, so that the system can calculate that the distance or the object position or the depth, etc. So this is the stereo camera. Then the third is our surrounding view, which is 360-degree. So basically this system combines images from multiple cameras, typically from the fourth hour like fisheye, I will say, cameras are mounted around the vehicle. So their location are in the front of, yeah, rear, left side mirror, right side mirror. They are placed in different locations, and their application is just in the case of parking and tight spaces if you have to. there are some type spaces. So there is very this sense cameras are very helpful. And one of the is our rear view for the reverse parking, rear obstacle detection. Okay. And also you can see here some types as just I have discussed with you, like monocular, stereo, sounded view, and their purpose as well. This is the thermal IR vagera, etc. Till now, anyone have any doubt or query? Please, you can unmute yourself. Is everything going good?
Yes, sir. If we can have comparative cost analysis of all these types of sensors, that would be great.
Sorry, can you just repeat it again?
If we were to have a cost comparison between all these systems,
Uh,
camera, LiDAR,
what's your name, by the way?
Shlok,
Shlok, actually, the cost depends on the quality or which quality or which company's product you are buying. We can't uh, tell you the exact cost or exact difference between the cost of each component here due to some copyrights, or we can say that the some company's issue, so we can't able to show you the costing, etc. But I will just can suggest you that if you will go to the market, or if you if you will research about these things, you can easily find the difference between the camera. Suppose you are buying the monocular camera for your vehicle, or the three, or the rear view camera, you can easily find the better costing, which will be able to, like, you can able to like buy that. Okay. So there is nothing I will discuss about this costing part. Okay, sorry for that. But I can just suggest you can just research about this because costing we can't discuss here, right?
okay.
Okay. Anyone else? Anyone else have any doubt? You can just turn on your mic and please speak, as I'm continuously speaking from the past 1 hour. No one has opened, like no one is asking some question. Is everything going good?
Modo. Yes, sir. Yes, sir.
Going
Modo.
good. Great, great, great. Okay, let's move forward. The next uh, comes our camera systems. Okay. So basically, as you can see here, the images, what cameras can detect, as I was just mentioned before, the traffic signs and the signals, and pedestrian, cyclist, lane marking, boundaries. By this image, you can able to see that how this, how actually exactly looks like. So yeah, so like the one question I will ask you, like, can a 2 megapixel mobile camera and a 108 megapixel mobile camera can capture the same level of detail? Will it able to capture the same level of detail? Obviously not, right? Similarly, in the performance of ADAS camera depends on several technical parameters. Okay. That's what I was saying. I can't able to tell you the costing about the costing, because it depends on the quality or the camera you are buying for your vehicle. Okay. So similarly, in the performance of this, there are some technical parameters like resolution, 128 megapixel, frame rate, dynamic range, and the field of view. Okay. First is our resolution, and we all know that about this megapixel things, because we all use mobile phones. Just after buying, like just before buying the mobile, we first check our uh, how much megapixel of camera this mobile has. So first we check the resolution. Okay. So this is suppose your camera is around 8 megapixel, that will be like a better sign detection. There will be a better sign detection and the better lane detection. Okay. Then the second thing is our frame rate. How many of you know about the frame rate? What is frame rate? Please explain. Maybe many of you have played PUBG.
It's FPS, frame per second. That's how
Yes,
many frame it can calculate and process under a second.
great. So yeah, so frame rate indicates how many images are captured every second. Okay, so here it is shows at 30 to 60 FPS. So it can capture up to 32 fps frame per seconds. Okay, now the third thing comes our dynamic range, which is HDR. HDR stands for high dynamic range. Okay, so it measures camera's ability to handle both very bright and very dark areas simultaneously. And why is it important? Suppose you are entering into a tunnel and exiting a tunnel. So that time the direct sunlight will hit. Uh, and suppose oncoming headlights at night will also uh, will like in the environment, it all those things happen. So without the HDR or the image will become too bright or too dark. Okay, so it will lead to missed detection. So with DDR, sorry, with HDR, the cameras can clearly see the roads, vehicle, and markings, traffic signs. Then the fourth is our field of view. We have just discussed, which is around 120 to 180 degree for surround and narrow for 30 to 50 degree. So it is used for surround the view system and the parking assist, blind spot monitoring, and this is for long range forward detection. All right, now let's move forward. Uh, as we I hope you don't have doubt till now. As you can see here, some semantic segmentation. This is also just showing you that okay, modern ADAS cameras rely on convolutional neural network, CNNs. Okay, so basically this is nothing but just a specialized AI model. Okay, so this is nothing just AI model which is designed for understanding the image. So it is just object. It will do object detection, then semantic segmentation, like label every pixels. Then it will do the optical flow. Then the depth estimation. Okay, basically this is the depth estimation can its main purpose is to just estimate the object distance and road geometry. And I will say that the application it is used in obstacle detection and just the lane keeping thing. Okay, because this is only for the depth estimation part. Okay, now let's move forward and understand about this sensor fusing. Let me just drink some water. Okay, all right. Yeah. So what is sensor fusion? So yeah. So this sensor fusion is like the process of combining data from multiple sensors to create a more accurate, reliable, and complete understanding of the vehicle surroundings. Okay, so instead of depending on a single sensor, this modern ADAS system combines the information from lidar, cameras, radar, and ultrasonic sensors. Okay, so it will show the fused view. How it shows? It shows a fused view, like more accurate. It will be more accurate, more reliable, and more complete. So what basically each sensors contributes here in the lidar, because lidar provides the accurate 3D point cloud, right? And the camera gives the 2D image, and the radar gives the velocity and the range, and the ultrasonic detects the close range, and it basically works on the parking space. Okay, and suppose your some vehicle is like passing nearby to your vehicle, it will these sensors, ultrasonic sensor is only for the close ranges. Okay, so now you can see the image. This is this camera shows the pedestrians, and radar says suppose this, in this image the radar is showing that this pedestrian is around 30 meters. Okay, and like ultrasonic is showing up the obstacle is around 1 meter away. So this is how the fused view looks like. It is just a combination of all the sensors, multiple sensor, to produce a more accurate, reliable and complete picture. Okay, and why is it necessary? Because no single sensors can do everything. So the fusion cover each sensor's weakness, and it as you can see here, in the fog it works very well, and in the night it also works very well, and in the high detail need, it also the camera gives the good details. So this is how the sensor fusion looks like or works like. Okay, now let's see some levels of this sensor fusion. Okay. So first you can see here, the first level is the low level raw data. Second one is our mid level feature, and the third one is the high level decisions. So basically why they have given these levels? Because depending on where the fusion occurs or the sensor fusion, it had to divide into three levels, because for the ray data and the feature fusions, and to like for the high level fusion of decision fusion. So basically first is our low level. So in this you can see the description here: fuse RAS sensors directly means, and how it works, because instead of processing the census data separately, the system combines the ray data and directly from the different sensors. For example, lidar provides raw point of cloud data. You can see here in the picture, lidar plus radar, it gives a point cloud radar returns. Okay, so both data streams are merged before any object detection or classification take place. Okay, then the second is our mid-level feature. So it basically extract feature first, then fuse it. Understood? So like instead of combining the ray sensors data or each sensors, first it extracts the useful feature, and the useful feature will be vehicle boundaries, lane marking, pedestrians. Okay, so the radar extracts the distance, speed, or the object position, and these extracted feature, and then we get the combined image. Here you can see the combined camera bouncing back, bounding boxes plus radar velocity. Then the third comes our is high level. Okay, I hope you all are making the notes as well, side by side. Okay, or you can just take the screenshot, okay, for the future use. Okay, so the third thing comes is our high level decisions. So basically how it works, each sensors in this independently analyzes the environment and makes its own decision. Okay, and the decisions are gets combined again, and it will gives us the decision fusion, or the final decision we can say here. Okay, this is about the levels of sensor fusion. Now let's move forward about the modern architecture of BEV. What bird's eye view is, and what bird's eye view fusion is. Okay, so basically this BEV creates a top-down view of the environment, similarly to how our drone would see the road from above. Okay, so like instead of processing the camera or lidar and the radar data separately, all the sensors information is converted into common top-down coordinate system. As you can see here, the one table is a step-by-step information is made here. Okay, so the question comes is, why do we need this bird's eye view? Bird's eye view. So basically, can anyone tell me why do we need this bird's eye view? Anyone, please turn on your mic. Can anyone explain?
So I guess it helps in parking assist, or like we can see what are the vehicles and pedestrians all around.
Yeah, it's correct. But the main function of this bird's eye view is mostly you won't see in the low cost vehicles, but basically this bird's eye view is basically given on the very costly vehicles, just for a 3D view. When you maybe have seen some vehicles, some concept models as well, they gives the bird's eye view just to see the surrounding of your vehicle. Suppose your vehicle, you can also see your vehicle on the screen, and continuously you can also see the surroundings of your vehicle, like which vehicle model is going along with your vehicle, or like is there a animal on the roadside, or is there any building on the roadside and some person is going or not. So all these things captured by this bird's eye view. As you can see here in the picture, there is a some, this is how the bird's eye view looks like. So basically this real time digital, I will say the it will gives a digital map. Okay, so where all the like detected objects are displayed in their exact position. Okay, so some Tesla, yeah, Tesla is one of the best example. Tesla basically primarily uses these cameras. It's I will there are some vision based BEVs. You can see here some Tesla occupancy network of pure vision BEV, Waymo multi-sensor BEV fusion, and BEV fusion plus camera. So basically, this is for the Tesla. Then the Waymo combines the lidar, camera, radar. All these things are combined also in this Waymo. And BEV fusion is MIT is written here because researchers at in the MIT introduced this BEV fusion. This is also the combination of camera, lidar, or the radar system. Okay, and if I will, if you will can see, if you can see here is the unified BEV representation. So you can see here the complete top-down map showing the car, pedestrian, all those things. So basically, this it is 3D map you can see here. Okay, now let's understand about how basically this I'm really sorry for that, it automatically gets back just as well. Okay, so let's understand step by step how it basically processes or how it works. Okay, now in the first step you can see here is the sensors data. Sensors data means camera plus lidar plus radar. So this process start with camera, which collects the raw environmental data. Then the pre-processing and the synchronization happens. So like all sensors data must be synchronized here, because camera has different configuration, like 30 fps it can create. Lidar has around 10 to 20 hertz, and radar suppose can take up to 20 to 50 hertz. So they all have different they all operate differently. So these sensors get aligned them in times. So okay, so this ensures like all sensors describes the environment at the same moment. Okay, then comes our future extraction. It is basically nothing but just like a camera feature, okay, which helps to detect the vehicle, etc. Then the spatial alignment comes. You see, this is like very important. Each sensors in this like sees the world from different location. So camera is behind the windshield. Okay, as we have just discussed the 4D view as well. Okay, so then comes our data association. Basically in this, suppose the camera detects a car, and you can see here and the lidar detects a 3D object, or the radar detects the like moving, suppose it is moving at a like 20 or 12 meter per second, whatever it is. Okay, so they all belong to the like same vehicle. Okay, then the next step comes is our state estimation, or the Kalman filter, or the DL model, I will say. So in this, basically, once objects are identified, this vehicle predicts the position, speed. Okay, and the what Kalman filter shows, basically it shows us like a commonly used, it is like a commonly used mathematical algorithm for like tracking the movement objects. So it continuously predicts and updates the object motion. Then the seventh step is our object tracking and scene understanding. This is same like the above steps, and the next steps is the planning and control. So this is the final stage, and which is based on the bird's eye view. The vehicle decided to steering angle or acceleration, braking, everything inside this. Okay. Then now let's move forward. Now let's understand about some autonomous driving levels, which comes under the SAE J3016. Okay, so SAE is our Society of Automotive. Sorry, why it is getting back? Okay, so why? So SAE is basically the Society of Automotive Engineers. Society of Automotive Engineers. Please listen to my word carefully. I'm not able to write it clearly here. Okay, pardon me for this. Okay, so yeah, so there are some levels. I hope you have heard about the levels. In this vehicle there is LEDAS, like level 2 ADAS system, or the level 1 ADAS system, right? So basically LEDAS, sorry, the level 0 means there is no automation, means there is no nothing is happening in the level 0. Then you can see here in the fifth, level 5, it is fully automation. Okay, like there is no need of any driver, so it is fully automated. So this is the level 5 uh, of ADAS system. Okay, now let's understand about sorry. So yeah, so in the level 2 you can see here, mostly companies in the India like Mahindra, or like Tata, or many more companies, Suzuki also giving like giving in the latest launch of their vehicles like ADAS level 2, just for the safety reason, to and to get the NCAP safety ratings in the market. So when your vehicle get the safety rating around 5 stars, so people will automatically buy your car. Okay, so that is the reason they are giving level 2. But now let's understand, basically it is partially automation, means the vehicle can control the only just the steering, acceleration, or braking simultaneously. For example, if you will see that the Tesla autopilot or other vehicle, so there is not this type of level 2 ADAS system is used. Okay, as you can see, it controls both speed and steering simultaneously, and as you can see, some Tesla autopilot also has this feature. And then the third level is our conditional automation. Basically this system becomes responsible for driving under the specific condition, like these conditions basically are called as OOD. What? ODD, operational designed domain. Operational design domain. So basically ODD defines where and when the system can operate. Okay, so this is same in the this ODD is also is inside this level 4 ADAS system as well. So some of the examples like you can see here in the level 3 is Mercedes Drive Pilot, and if you will see in the level 4 there is Waymo, One Phoenix, Zoox, Robotaxi. Okay, so these are the best example. Okay, if you will understand about only for the level 4 and the level 5, so basically in this the vehicle can drive completely by itself. As you can see here, who monitors this? Only the system part. And in this only the system part is controlling, and it can automatically drive by itself. Okay, so level 4 operates only inside. Okay, uh, no driver need is needed in this defined operational design domain. And also in this level 5, there is no need of no driver ever, and like any condition. One of the most thing is because it is like completely human level driving capability it has in this level 5. And companies, as we all know, that if this ADAS system comes to in our India, is it work or not? Because you can see that the traffic's in the market, how much traffic, and people don't follow the traffic rules or signs, right? So do you think that this will work in the India? Maybe in the future it will work, hoping for the 2047 Viksit Bharat. Okay. So yeah, so this is about the autonomous driving's levels. Okay, now let's see, this is also just same thing I have just discussed with you. This is level 2 and level 3, human is responsible, same as that. If you want to take the screenshot, you can take it. uh, okay, now let's move forward. Okay, now let's understand about the one of the like most important one more thing is our ADAS architecture. So like when a vehicle detects an obstacle, like automatically applies the brake, and when like what happens, what is happening inside the vehicle, like most people think sensors directly activates the brake, but the reality is that like information passes through these multiple processing layers, right? So now let's you can see here you can see here the structure of this architecture of this ADAS. Okay, yeah, then the first thing comes here is our sensors layer, right? I hope you have understood about all these things, and I will only discuss the left out things. Okay, so here you can see the sensors layer in this. These things are coming. I'm just speeding up because we have to end this webinar uh, before or at around 6 p.m. Okay, so that's why I'm speeding up. But still, if any doubt comes to your mind, just unmute yourself. Okay. Then the second thing comes is our perception layer. Basically, this is where intelligence begins. The presumption, like this presumption layers answers like what I am looking at, like using the AI and the deep learning. The system identifies the object in this. Okay, and we all know that what object is trucks, cars, example for etc. So, and the lane detection, semantic segmentation, depth estimation. Then the fusion layer we also have discussed. After this, the LiDAR makes the fusion layer. In this, there is object tracking, scene up, understanding, occupancy grid. Then the ultrasonic sensor, what it does basically, it detects the localization layer, SD map matching, or the SLAM, or the GNS. Basically, I will say like this is what SLAM is. Basically, this is simultaneous localization and mapping. Okay, and what GNSS and IMU fusion is, basically it combines the GPS signals and motion sensors. Okay, then the next architecture is in the architecture is our planning layer, where the route planning happens. Okay, and the behavior planning happens, or the motion planning happens. Okay, and you can also see the trajectory generation. And in the last step you can see here is our control layer, where the automatically things happens, because it automatically controls your steering or the brake or the other commands as well. Okay, so, and if you will if you have seen that there is something like a communication behind all those things, is our CAN or the Ethernet, where the high speed communication is happening. to give the signals to the different components inside your vehicle. Okay. Now let's move forward. There are some key hardware components, and there are I have mentioned here some compute platforms as well. So basically, uh, you can see here some platforms and the company's name and the TOPS. Basically, some hard components are ECUs, which are used in the ADAS systems, or the domain controllers, or this, or one more thing is our zonal architecture. So basically, ECU, we all know that it is our electronic control unit. It is a small computer which is dedicated to a specially like a specific vehicle function, I will say, because I hope everyone know about this. A EV consists of around how much ECUs? Anyone? How much ECUs a electric vehicle can contain? Is there any rough idea you can also give me? So there are around 70 plus ECUs are used in a electric vehicle. Okay. Okay. So yeah. So basically, then I will talk about this domain controller. So to solve the issue complexity, or the manufacturer basically introduced this domain controller. A domain controller is nothing but just a powerful centralized computer that manages the multiple related functions. Okay. Uh, for example, cameras, radar, etc. Then the zonal architecture comes. Basically, this is the newest automotive architecture. Like many experts considered it the future of software defined vehicles, SDVs, software defined vehicles. So instead of organizing electronics by function, this vehicle is divided into physical zones: zone, ECU, this zone, this zone, this zone. So vehicle is getting divided into this zonal architecture in this technology. Okay. And and you also can see the some platforms here the Nvidia uses, and drive Thor. What it basically, what is TOPS? This is like trillion operation per seconds. Okay, this is trillion operation per second. Basically, it measures the AI processing capability. So you can see here the TOPS level of companies, each ECUs or the domain controllers. Okay, Qualcomm, all those things. Okay. And also use in the this L4 level 2 to level 4. This here it is mentioned in the ADAS level environment. Okay. And if I will talk about the software stack, so basically, the this is the operating system, Linux, or there are some other operating systems as well. So what basically software stack is? It is just like a collection of software layers which are working together, just like suppose a building has a foundation or some floors, then the rooms. So like an ADAS system also has like some multiple software layers. Okay, so each layers performs a specific task, and it supports the layer above it. Okay, you can see here the operating layer, the middleware layer, AI framework, and there are some safety standards and the communication thing. Okay, so basically this is the lowest software layer, which is our operating system, just like Windows, which runs on our laptop. Okay, so basically ADAS software runs on specialized automotive operating systems. These are the QNX and the AUTOSAR, you can see here, and the Linux. So many like autonomous vehicle companies use this Linux just because this Linux offers flexibility and open source development or the strong AI support. Okay, if I will talk about this uh, like QNX or the AUTOSAR, basically this is also one of the best operating system, because it gives us a real-time operating system. We also call it is RTOS. Okay, and AUTOSAR, we all know that It stands for automotive open system architecture. Automotive open system architecture. It is not exactly an operating system. Basically, it is standardized software architecture which is used across the automotive industry. Okay. Then the second is our middleware layer. It acts as a like bridge between the operating system and the application software. Okay. Then in this you can see here the ROS2. Basically, it is a robot operating system. Okay. Then the next comes our AI framework. So basically, we reach to the like intelligence layer where you can see the Tensor RT NVIDIA. So it is like a AI optimization framework. So basically, its purpose is nothing but just to make the AI models, okay, for the faster or most efficient lower latency. Then comes the OpenVINO. Basically, it is Intel AI framework. Okay, and same for this ONNX runtime. And there are some safety standards as well for this. Okay. And safety standards like ISO 2626, which is for the functional safety, and for the cyber security, this is the ISO given. And the last you can see here, the which is our communication system, which will happen through with the help of CAN bus or CAN FD, CAN flexible data rate, or some CAN XL as well. For the faster communication, we use this type of communication. And one more communication is our LIN, but it is a low speed communication. We don't use it in the ADAS system. We only use high speed communication. Okay. So this is about the software stack which is used in the ADAS system. Okay. Now you can see here some EVs and ADAS integration. Just please stay with me for next 10 to 15 minutes. I will complete it. Okay. Don't worry. Don't leave. You will get the certificates as well, and you will also getting the knowledge as well. Right. So don't left the meeting or the session. Sorry. Now you can see here the EV and the ADAS integration. Okay. So like you can see here some traditional vehicles which rely on the like heavily on the mechanical systems or the hydraulic system, right? So basically EV, what where will EV rely? So basically EV rely on the electronic controllers or the softwares, or like I will say the physical linkages. Okay, so basically a computer is running on wheels. You can see here. Okay, or there is a totally computer here. And this is about the regenerative braking system. How many of you know about the regenerative braking system? Please, anyone can explain me about the regenerative braking system?
The motor acts as a generator while
Yes.
braking,
Yes.
and that stops the vehicle or reduces the speed.
Yes, exactly. So like when your vehicle moves, so that time when the driver releases the accelerator or applies the brake, that time the kinetic energy is getting converted into electrical energy, and it gets sent back to the inverter part, because the generated electricity is in the form of AC, and the inverter converts it into the DC supply and sent directly back to the battery part, and that energy gets stored into the battery. So here is one more thing, the ADAS system in the EV coordinate with regenerative braking system, because the same thing I have already explained in the starting, because it applies brake automatically. So this also helps us to improve the efficiency of our electric vehicle. There is nothing much more than that in this EV and ADAS integration. This is one of the best example, I will say. Okay. Yeah. So this is like one of the same thing which is V2X, I will say like vehicle to everything integration. This is does anyone know about this vehicle to everything integration? You can unmute yourself. Anyone?
Yes.
No, no issues.
Yes,
I
sir.
am here to
We have
explain you. Oh, yeah, sorry.
Yes, I heard about it.
Yeah, because everyone nowadays learning or studying about these technology V2X and V2V technology, which is vehicle to vehicle, and there here it is vehicle to everything. Okay. So yeah, basically this until now we have discussed about just ADAS use sensors, which are cameras, radar. So but all these sensors have one limitation, right? So because they can only see what is within their sensing range, right? So but after that, what will happen? So like how can the vehicle know about the hidden, like about that hidden danger? So basically the answer is just nothing but just a vehicle to everything integration. So this vehicle V2X allows a vehicle to communicate wirelessly with all other vehicles or the road infrastructure. Uh, or the in this technology there is like a cloud service, and there is one vehicle to grid function as well. As you can see here, the first one is our vehicle to vehicle configuration. Okay, so basically V2X is important just because the traditional ADAS relies on this sensors based awareness system, because this V2X adds the cooperative awareness. Now like vehicles can share information and warn each other before a danger becomes visible. Okay, now you can see here in the vehicle to vehicle, basically in this vehicle communicating directly with other vehicles. Okay, so what information is shared is they exchange the position, they exchange the position of their vehicle or the speed, direction, actions. Okay, or for example, suppose a car which is ahead suddenly brakes. So instead of waiting for the radar detection, the vehicle immediately broadcast the emergency braking, and the nearby vehicle which nears the next vehicle, so it will receive the warning instantly. Okay, then the next comes our vehicle to infrastructure. Basically in this nothing but just this communication between vehicle and road infrastructure. Um you can see here the traffic light, tool booths, construction zone. So a traffic light sends information, so signal will turn red. Suppose here the signal is turning red into the next is second, the signal will turn into the red, so the vehicle knows this before reaching the intersection. Okay, so this benefits the ADAS, which slows down so smoothly or easily, I will say. Then you can see here the V2C, which is our vehicle to cloud. It gives the OTA updates. V2C is basically it is communicating with the cloud service. Okay, so it is just information, changing the information. Like when the vehicle uploads the driving data or the sensor data or the diagnostic information. So this cloud sends the software updates, HD map updates, because in the EV we don't use the oiling service, we use the software updates. So this is also like vehicle to cloud service, helps in diagnostic as well. Okay, then the vehicle to grid is as well, because especially EVs, in the EVs it is happen because in these EVs can act as a like consumer of electricity or the supplier of electricity. Okay, so suppose for example there is a pure during like peak demand, the EV battery can send back power to the electrical grid as well. Okay, so this is all about the V2X or the V2V, V2G, V2C, and V2I infra configuration or integration system things. Okay, and this is the same thing which I have just discussed, because this is over the air updates. Basically, most students uh, don't know about this technology, because it is used only in the Tesla models, and many pupils like when they go to the serving stations, uh, there is one systems comes that it is the OTA updates. Suppose this is nothing but just like it processes remotely updates the vehicle software using the Wi-Fi, because most of us we go to the service center and do the updates, right? But it is over the air updates, because same as that we do in the mobile phones, or because automatically update comes to our mobile and we will update it, right? So but in same in this over the air update, which is critical for the ADAS system. Okay, so it is just important for the ADAS. Okay, as you can see here, Tesla has delivered new FSD feature, new ADAS mods, and bug fixes via OTA. So in this, Tesla has fixed the bugs via the OTA update. So you don't have to go to the service center. You can easily update your vehicle at your home. Okay, so this is about the OT updates. Now let's move forward and let's see the EV specific ADAS features. Uh, we are just reaching to the end of this session, and there is one announcement. Please stay. Okay, so this is the specific ADAS feature. I will say this is the predictive charging. There are some battery aware routing and the regeneration integrated ACC we have just discussed, and some intelligent speed assist regeneration and the auto lane changing highway. We all have discussed all those features in the previous slides. Okay, and this is the smart summon auto park feature, which comes because you can easily park your vehicle with the help of one application you can install on your mobile phones. Okay, so this will help you to just manually or sitting at a chair, you can easily park your vehicle. Okay, so this is the most advanced features in the, and this is nothing but just a notable EVs, plus there are some ADAS example for your reference. As you can see here, this is the Tesla Model 3 YSX Cybertruck, and the Mercedes BMW IQ iX. Okay, and these are nothing but just some examples for your reference, because these cars have best in the segments. They have those have the best ADAS system. Okay, and this is the future mobility. This is the last slide, and after this there is one announcement. uh, okay, so this is the future of our EVs. In the future, you will see that there are some software defined vehicles, or there will be like robot taxis, AI and foundation models in that as SD maps and dynamic mapping, 5G and edge computing, right? And you can see here some case conversions, safety and regulation, urban air mobility. This is like extremely, when you will see on the 2050 or the 2060, you will see that the vehicles are moving in the air. Okay, so this is it uh, for the today's webinar. Okay, now please you can unmute yourself. We came to the end of this session. Is Pratham?
Sir,
Yeah.
as of our competition, also have an autonomous round
Okay.
where we have to occupy our vehicles with uh, chosen sensors, and we have to navigate our vehicles between cones
Can
of
you just speak it louder, because I can't able to hear you clearly. Yeah.
hello sir,
Yeah. Yeah.
am I
Yes.
audible?
Now it's clear. Yeah. Now it's clear.
Yeah, as of our competition, we are required to have an autonomous system where our vehicle has to move to a specific track, which has a boundary of cones. So it is similar to ADAS level 3, which uh, we will have an defined
You can speak.
environment.
You can speak in Hindi as well. Yeah. Yeah.
Yeah, so which can you give us a roadmap So how our sensors we can integrate with our uh, onboard computing system, and how will that work? Because we talked throughout the how sensor works, which sensors have which advantages, but how do we compute that data? That we haven't
So
discussed yet.
yeah, like most of the things I have discussed in this webinar, and I hope you have all understood about what exactly the function of each sensors or each radar system. But you are talking about the, like, you want to do the integration, how you can choose the best sensors for your vehicle, right?
Yes, sir.
So basically look, so like if you are building your own vehicle, or you want to do the configuration by according to your need, so there are many sensors. Like suppose are you making the two wheeler or the four wheeler?
It's a four-wheeler.
It's a four wheeler. Is it for the formula?
No, it's for ESVC, electric
ESVC,
solar
right?
vehicle.
Okay, okay. Yeah. So there are many sensors, like we have just I have just mentioned you, like suppose you have to do the auto parking, or there are some lane detection sensors, or suppose suppose you want to do the integration for the like collision detection, right? So there you should choose a sensor according to the range. Suppose there are many sensor which gives not more than 20 meter or 50 meter of range. Or suppose you want to do the parking of your vehicle, there we use the ultrasonic sensors. So when you choose your ultrasonic sensors to if you want to choose the sensors to integrate with the vehicle, there you can choose your ultrasonic sensor, just because uh, it will help you to avoid the collisions, because it will automatically gives the warning whenever you will park your vehicle. Like it is one of the simple sensors, I will say, that you can choose for your vehicle. And one more sensors you can choose is the uh, or the camera, I will say, that you can choose the stereotype camera, or you can simply choose the one of the example I have given before is the, let me just share you. Is my screen visible to you all?
Yes, sir.
Okay, as you can see here, some the camera types I have shown here you is this is the simplest camera you can choose here for the reverse view. Whenever you will reverse your vehicle, it will help you to see the uh, rear angle as well. Okay, and the monocular camera you can also choose for your vehicle for the lane detection or the signal recognition. Okay, so also I will guide you, like if you want, I will guide you as well after the session. I will talk with the Rajiv sir, and if you have any doubt and query regarding anything, so I will also help you on that. Okay.
Yes, sir. Because uh, even after choosing a sensor, how
Yeah.
to process the data, that's the more important step. That we
Yes. Yes.
can choose the sensor, but which OS to choose, which software, like you said, ROS or AutoSAR, and how to use it in our application. That is more important to us. And we currently don't have the way, a roadmap to how to use those for our project.
Okay, Shalok, no worries. Now you have told me your query. For the next webinar, I will. It will be for the configuration and all those, how you can integrate and how you can uh, choose the cameras and how you can do the OS things. Okay, I will for the next webinar. Let's take this topic, and we will learn about all those things, how you can choose. Like today we have discussed about all those ADAS system, what will happen, what things happens inside this. But in the next session or webinar, we will discuss all the roadmap you need, okay, to integrate all the sensors in your vehicle. Okay, don't worry, no worries about this. I have written this, so we will be taking this next webinar. Okay.
Okay, sir. Thank you.
Okay, anyone else?
Sorry, sir. Hello.
Yes, Edwin.
Sorry. I want this notes. Yeah. Can you send? Okay, you can send us this notes.
Edwin, your voice is not clear. Can you just repeat it?
I need this notes. So can you send us this notes?
Yeah, Edwin. I will first confirm with the seniors or the organizer team. Then I will definitely give you some audio or the some notes about today's webinar. Okay, don't worry.
Okay. Thank you.
Okay. Is anyone else? There is one announcement. Rajiv sir. Rajiv sir, can you? Is Pratham available here? Okay.
Yeah,
Okay. Pratham, you can continue. Please don't left anyone.
yeah. So very good evening, everyone. This side Pratham, and like I'm going to introduce to our like master certification EV technology course, which is approved by certificate AICT. So basically, like is a 6-month program in which you will be providing live classes at ISIE certified EV labs. Then you will be given an industry relevant curriculum designed and taught by industry experts. Then there is a hands-on project industry specific tool. Then we are going to give you access to interview opportunities in top EV companies. And plus there is a dedicated career support, which will help you providing interview preparation. And obviously when you complete this program, you will get a valid ISIE certificate, like which is obviously globally approved. So all the details of this, like Rajiv sir will share a form in the chat. You just have to like fill the form and our team will contact you. Okay. Okay, so Rajesh sir, please like share the
Okay,
form.
students, you can scan here with your devices to get the brochure of the AICT certification course. Okay, so yeah, so you can just scan it here. If you want further information, so Pratham will guide you on this. Okay.
Yeah, just scan this QR and
Yes.
So what is the fees of the course?
Sorry.
What is the fees?
These all things will be discussed if you will like share your interest on this. We will guide you separately, uh, and we will also give you the insights about this course, what is different in this course and what makes this course different from other courses. You will definitely yeah. So Raju sir, actually this QR is only for the brochure I have mentioned here, but when you will fill the Google form, we will get back to you. Okay.
Sir, good evening. I am from summer internship batch, sir. Sir, today class has been occurred at 2 p.m. to 3 p.m. Sir, I am working an offline internship in another company, so I could not attend this class, sir. So please kindly keep the classes in evening session, sir. So it will be useful for me to attend live interactive sessions with sir.
What's your name? What's your name, by the way?
Sir, my name is Gopi Karthik, sir. Yesterday session, orientation session, I attended, sir, in Govindan Kumar ID. I yesterday self told my queries, sir.
Gopi Karthik, actually, yeah. So actually, we have to conduct the today's session at 2 to 3 p.m. just because I have to take the webinar. So in the next, maybe you will get updated about the next session. The timings will get changed. It may be around 5 to 7 p.m. So I think it will be comfortable for you.
Sir.
Yeah.
Yes, sir. I already conveyed my query. He also assisting me.
No issue, Gopi Karthik. We will resolve your issue. Okay.
Okay, sir. Thank you, sir. Okay, sir.
Okay. Thank you so much.